A colossal stone face stares back at you, polished to a mirror finish by hands that should not have possessed the tools to do it. This is the enduring mystery of ancient stone carving techniques, a puzzle that defies our standard history books. By the end of this journey, you will see the ancient world not as a primitive prelude, but as a place of profound and forgotten mastery. How did cultures across the globe shape granite as if it were soft clay? And why does their flawless workmanship still outpace modern attempts at explanation? The answers force us to rewrite everything we thought we knew about human innovation. What does true craftsmanship look like when it leaves no trace of how it was done? Granite is harder than the steel used to cut it today, yet ancient artisans treated it like soft clay. This is the heart of the mystery, a gap in our understanding so wide it feels like a missing chapter from the history of technology. We are not looking at simple monuments. We are examining objects with surfaces polished to a glass-like sheen, corners cut with geometric perfection, and blocks fitted together so tightly that not even a blade of grass can slip between them. The defining challenge is threefold. First, the material itself. Cultures from Egypt to Peru chose diorite, granite, and basalt, stones of immense hardness, for their most important works. Second, the assembly. They created massive, complex structures from countless individual stones, locking them together without any binding mortar, relying solely on flawless cuts. And third, the scale of replication. This wasn't a happy accident. The same impossible precision was achieved repeatedly across continents and centuries in projects involving thousands of laborers. As historian John Anthony West pondered, does this point to a forgotten science? When you see a 200-ton block of granite with a surface as smooth as a modern countertop, carved with intricate hieroglyphs, you have to ask what tools or what knowledge could possibly leave such a clean, confident signature. The evidence is right in front of us, etched in stone, waiting for an explanation that makes sense. The first enigma takes us high into the Andes Mountains, to the fortress of Saxehuaman. Here, the stonework does not just defy explanation, it mocks it. The walls are built from colossal blocks, some heavier than a fully loaded semi-truck, each one a unique and irregular shape. Yet they lock together in a three-dimensional stone puzzle so flawless that the seams between them have vanished. For centuries, visitors have tested this claim, attempting to slide a piece of paper or even the thin edge of a razor blade into those joints. They cannot. The fit is that perfect. The standard historical explanation suggests that teams of workers laboriously pounded these boulders with other, harder stones, slowly shaping them over countless years through sheer effort. But this idea hits a wall of its own. How does trial and error pounding produce such intricate, interlocking contours? How does it account for the perfect flatness of the contact surfaces, hidden from view? The sheer scale of the site, with thousands of these perfectly fitted stones, makes the notion of endless manual shaping feel almost as improbable as magic. This has led to quieter, more speculative theories. Could the builders have used a natural plant compound to temporarily soften the stone's surface, allowing for precise molding? Did they possess an advanced understanding of stone fracture, similar to how a master glassworker shapes their material? Some even point to local legends that speak of a substance that made stone flow like clay. While we may never identify a single tool, the true revelation of Saxehuaman is not in a hypothetical chemical, but in the evidence of a system. The precision is consistent, replicated across vast projects. This suggests something far more powerful than a secret recipe. It points to a lost language of construction, a unified set of principles and templates so effective that it turned mountain rock into a form of architectural fabric. The stones themselves are the only remaining pages of that forgotten manual. but the mystery of shaping stone pales before the challenge of hollowing it out. For our second enigma, we must descend into the silent darkness beneath the sands of Saqqara, into the tunnels of the Serapeum. Here, in this sacred resting place, you do not find fitted walls but solitary, monumental objects. They are colossal boxes, each carved from a single, immense block of red granite, a material so hard it sparks under modern steel tools. Each of these sarcophagi weighs approximately 70 tons, the equivalent of a full battle tank. Yet their true wonder is not their mass but their impossible interior geometry. Inside, every surface is flawlessly flat. Every corner is a perfect 90-degree angle, sharp enough to cut a shadow. The precision is so absolute, so clean, it looks like the work of a gigantic computer-guided milling machine. The lid alone, a slab of stone several tons in weight, fits its base with a seam so tight it creates an airtight seal. This is the core of the conundrum. How do you achieve such machined perfection inside a sealed granite box, using only the simple tools our history books grant to the Bronze Age? The accepted tools of copper chisels and stone hammers are not just inadequate for this task, they are almost comically so. Copper is significantly softer than granite. You cannot carve granite with copper any more than you can carve a diamond with a stick of butter. Modern experiments have tried, and the results are telling. The copper tools deform and blunt almost immediately. The granite does not yield in clean cuts, it fractures and chips unpredictably. To create the Serapeum boxes with such tools would be like trying to sculpt a flawless crystal vase using only a hammer, a task not of patience but of physical impossibility. This glaring disconnect forces a difficult question. Were the tools we have found in the archaeological record merely for finishing touches or for softer stone? Could the real technology have been something else entirely, something that has not survived the ages? Some researchers point to the potential of abrasive slurries, mixtures of water, and a grinding powder harder than granite, perhaps using crushed quartz or even a form of early corundum. With such a slurry and a flat piece of wood or stone as a guide, one could, in theory, slowly saw and grind the granite to a flat surface. Others wonder about lost alloys, a metal harder than copper that has since corroded away or been repurposed. This idea pushes at the very boundaries of accepted Egyptology, suggesting a technological branch we have yet to discover. The silent boxes of the Serapeum offer no written instructions. They simply sit in their eternal darkness, their perfect surfaces a silent, stubborn rebuke to every simple explanation. They are not just containers, they are three-dimensional puzzles, and their solution may rewrite our understanding of craftsmanship itself. If the Serapeum boxes represent a mastery of hollowing stone, then the stones of Puma Punku in the Bolivian highlands represent something even more disorienting. They showcase a mastery of geometry and mass production that feels eerily modern. Scattered across this windswept plateau are shattered blocks of andesite, a volcanic stone as hard as granite. But these are not rough boulders. They are precision-cut components like pieces from a colossal stone machine that was taken apart and never reassembled. What you see are not random fractures but deliberate, intricate cuts. There are blocks with perfect 90-degree notches that look like giant stone brackets. Others have clean, straight channels carved into their faces, forming perfect H shapes or T shapes. The edges of these cuts are razor-sharp, with no sign of the chipping or uneven where you would expect from hand tools. The uniformity is what truly stops the breath. Dozens, even hundreds of these stone pieces share identical features, as if they were all stamped out from the same set of master templates. This suggests a system, a repeatable process for creating interchangeable parts. That idea alone, a form of industrial standardization in a place and time we consider ancient, is a profound challenge to our historical timeline. How do you explain a prehistoric assembly line? the mystery takes an even more precise turn when you examine the drill holes. Some of these stones feature perfectly cylindrical holes, bored straight through the dense andesite. But the real clue is in a specific type of hole known as a countersink. This is where the entrance of the hole is widened into a shallow, conical depression, allowing a fastener or a plug to sit flush with the surface. Creating a simple hole in hard stone with a hand-powered drill is one thing. Creating a hole with a perfectly symmetrical, widened opening at the top speaks to a tool with consistent control and pressure, something like a tube drill mounted in a stable frame. It implies not just a tool but a technique, a practiced method applied again and again. Could this be the evidence of a sophisticated, tool-based stone-working industry that has otherwise vanished from the record? The alternative is even more staggering to consider, that our understanding of Andean history is missing a crucial chapter, one where a culture achieved a level of technical prowess we have not yet credited to them. The silent, scattered stones of Puma Punku do not tell us a story of gradual progress. They present a snapshot of a finished technology, a puzzle where the instructions have been lost, leaving only the perfectly machined pieces behind. From the colossal to the delicate, the stoneworking mystery takes a breathtaking turn. We now move from architecture to artistry, to a class of objects so finely made they seem to defy the very laws of physics. These are the hard stone vases of ancient Egypt, dating back to its earliest eras. They were not carved from soft alabaster, but from some of the most challenging materials on Earth, like schist, basalt, and even crystalline rock. To hold one is to hold a paradox. The exterior might be beautifully fluted or elegantly curved, but the true magic is hidden inside. These vases possess long, slender necks that open into wide, rounded bodies. The interior curve where the neck meets the shoulder is a perfect, undercut hollow, a shape impossible to create with any simple hand tool. Most astonishing of all, the walls of these vessels are of a consistent, and sometimes paper-thin, thickness throughout. The symmetry is flawless, as if the vase was spun on a wheel while still solid stone. This level of interior precision is the core of this fourth enigma. The accepted explanation involves a bow-driven drill, a simple tool where a copper-tipped bit is spun back and forth by a handheld bow. But try to imagine using that method on a block of granite to create a thin-walled vase. The copper tip would quickly dull against the harder stone. The irregular back-and-forth motion would create a rough, asymmetrical hole, not a smooth, perfect curve. The fragile neck would likely snap under the pressure. The vases themselves provide the evidence, or rather, the lack of it. They show none of the telltale spiral marks or uneven gouging that such a primitive drill would inevitably leave behind. Their surfaces, inside and out, are often polished to a high, uniform sheen. This has led some researchers, like engineer Christopher Dunn, to a controversial but compelling theory. He suggests these objects show signs of being turned on a fixed, mechanically powered lathe and hollowed out with a milling tool that moved with steady, constant force. Think of a modern potter's wheel, but one powerful enough to spin solid granite, with a cutting tool held firmly against it to shave away precise, even layers. This idea is not about finding a literal machine in the sand, but about recognizing a specific type of precision that implies a specific type of technology. The concept is staggering. It proposes that ancient artisans might have achieved a technological peak in precision machining, a peak that was later lost for centuries. What does that mean for our linear view of progress? It raises a profound and humbling question about the trajectory of human knowledge. Can a civilization master a complex art so completely, only to have the principles behind it fade from memory, leaving behind only the perfect, inexplicable artifacts as proof it was ever done at all? These vases are not just containers, they are silent witnesses to a forgotten standard of craftsmanship, a standard that quietly asks us how such delicate perfection emerged from an age of supposed simplicity. This fundamental mismatch between tool and material is where the mystery truly begins to deepen. To grasp why these ancient achievements are so baffling, we need to get a feel for the stone itself. Think of the toughest substance you encounter in daily life, maybe the glass on your phone screen or the ceramic of a coffee mug. Now imagine something exponentially harder, a material that would shatter those everyday objects without receiving a scratch. That is the realm of granite, diorite, and basalt. These are not simple rocks you can chip away with a hammer. They are igneous and metamorphic stones, forged under immense heat and pressure deep within the earth, making them incredibly dense and resistant. On the scientific scale used to measure hardness, called the Mohs scale, these stones sit between a 6 and an 8. For a crucial point of comparison, the quartz crystals naturally embedded within granite are a 7 on that same scale. Now consider the primary metal our history books say was available for tools during the eras these monuments were built: copper. Copper registers at only a 3 on the Mohs scale. The difference is not just a gap, it is a chasm. You cannot meaningfully shape a material that is more than twice as hard as your cutting tool. The copper would simply deform, flatten, and wear away against the unyielding stone. It is not a matter of patience or effort. It is a basic law of physics, like trying to cut a steel beam with a piece of chalk. This undeniable fact forces a pivotal question, one that shifts the mystery from how they built these things to what they were actually using to build them. The choice of material itself becomes a powerful clue. Why would any culture, especially one we perceive as early or limited in technology, consistently choose the most difficult stone possible for their most important, enduring projects unless they possessed a method to work it effectively? This leads to two compelling lines of thought. The first is the idea of a lost process that could temporarily alter the stone's property. Could there have been a plant-based chemical compound, or a method of applying precise, controlled heat that made the surface of the granite temporarily softer or more malleable, allowing for shaping before it hardened back to its full strength? Local legends in various parts of the world sometimes hint at such knowledge, speaking of liquids that made stone behave like clay. While no direct archaeological evidence for such a substance has been confirmed, the persistent choice of impossible stone keeps the question alive. The second, and perhaps more tangible, theory involves abrasives. If you cannot cut a hard substance, you can grind it away with something even harder. This is the principle behind modern diamond-tipped saws. Did these ancient cultures discover and utilize naturally occurring abrasives that were harder than the quartz in their granite? Conundrum, which includes rubies and sapphires, is a 9 on the Mohs scale. Even diamond dust, though rare, could have been collected. The theory suggests that these ultra-hard powders were mixed with water to create a grinding slurry. Then, by using a simple saw made of wood or soft copper with this abrasive slurry trapped under it, and by moving it back and forth with relentless consistency, you could slowly saw through even the hardest granite. The same slurry could be used with a tubular drill, a hollow reed or copper tube, to bore those perfectly circular holes. This method does not require magic metals or forgotten chemistry, just a profound understanding of material science and immense coordinated effort. It turns the act of carving from a cutting action into a grinding one. Yet, even this logical explanation meets challenges when confronted with the sheer scale and flawless finish of the work. Grinding a 70-ton granite box to a mirror-smooth, perfectly flat interior with handheld tools is a task of almost unimaginable duration and control. So while the abrasive theory provides a possible mechanical answer, it still leaves us in awe of the skill, organization, and unwavering standards of quality that such an approach would demand. The stone itself, therefore, is more than a building block. It is a deliberate statement, a testament placed in our path by the ancients, challenging us to recognize that their world contained depths of practical knowledge we are still striving to fully comprehend. The conventional toolkit of ancient history feels almost comforting in its simplicity. We are told of stone hammers, copper chisels, and wooden wedges soaked in water to split rock. For certain projects, this explanation fits perfectly. The mighty stones of Stonehenge, for example, show the telltale signs of such methods, their surfaces bearing the pockmarks of relentless pounding. This was a triumph of brute force and perseverance, a story we can easily understand. But when we turn our gaze to the mirror-polished granite of Egypt or the machined components of Puma Punku, that comforting narrative begins to crack. The tools we accept as standard issue simply cannot account for the evidence we see. This is the tool theory conundrum, a quiet but profound disconnect at the heart of the mystery. Modern experiments have put these accepted methods to the test. Teams of skilled artisans using exact replicas of copper chisels and stone pounders have attempted to recreate even simple hieroglyphs on a granite surface. The results are telling, and they are starkly different from the ancient originals. The copper tools dull within minutes, becoming useless against the harder stone. The work progresses with agonizing slowness, and the final product is crude and uneven, with jagged edges and a rough, fractured surface. There is no path from that experimental outcome to the clean, sharp, and confident lines found on a royal sarcophagus. The time required becomes another impossible barrier. If it takes a team days to produce a few crude inches of carving, how many lifetimes would be needed to complete an entire temple complex covered in flawless inscriptions? The math collapses under the weight of the ambition. The observed evidence demands something else entirely. It demands tools that could maintain a sharp, consistent cutting edge against a brutal material. It suggests the application of controlled rotational force, the kind that creates perfect drill holes and symmetrical vases. It implies a means of achieving and verifying flatness and perpendicular angles to a tolerance we would associate with modern engineering. The gap between the accepted toolset and the quality of the finished product is not a small discrepancy, it is a chasm. This chasm is what fuels decades of alternative research and quiet questioning within the field itself. It forces us to consider two unsettling possibilities, neither of which fits neatly into a linear history. The first is that a sophisticated, common body of stoneworking knowledge was somehow completely lost, a technological dark age that erased not just the tools but the very principles behind their use. The second, more speculative idea is that this precision represents the intermittent guidance of a more advanced technical culture, whose influence appears, fades, and then reappears in different parts of the world across millennia. This theme of a lost mentor or a forgotten peak of knowledge is a thread we will follow as our search continues, leading us from the question of how they built to the even deeper mystery of why they built with such impossible perfection. The silence of the stones is broken by a whisper of grit and water. To solve the tool gap, we must move beyond the idea of cutting and into the realm of grinding. This is the lost abrasive hypothesis, a theory that replaces the mystery of a magical tool with the practicality of a forgotten recipe. Imagine the hardest substance you know, and then seek out something even harder to grind it down. This is the simple, devastatingly effective principle that could explain the impossible. Common sand made of quartz is often proposed as this abrasive. But here lies a subtle flaw that reveals a deeper insight. The quartz in sand is a 7 on the Mohs scale, which is the same hardness as the quartz crystals naturally embedded within granite. Using quartz to grind granite is a battle of equals, a process of immense friction, and where that would be achingly slow, producing a rough, gritty finish, not the glass-like polish we observe. The ancient artisans would have known this. They were master material scientists, intimately familiar with the stones they revered. they would not have chosen an inefficient method for their most sacred projects. This leads to a compelling shift in the search. What if their abrasive was not common but chosen with precise knowledge? What if they used a powder made from a mineral significantly harder than their granite? Conundrum, the mineral that forms rubies and sapphires, rates a 9 on the Mohs scale. Emery, a natural mix of corundum and magnetite, is another powerful candidate. These materials exist in nature and, when ground into a fine dust and mixed with water or oil, create a super-effective cutting slurry. A simple copper saw, pulling this gritty mixture back and forth under its edge, could then slice through granite like a modern diamond wire saw, just infinitely slower. The same slurry in a hollow reed or copper tube spun by a bow drill could bore those perfect cylindrical holes. This theory turns the act of creation into one of relentless, controlled erosion. But the hypothesis ventures into even more intriguing territory with hints from ancient texts and mineralogical studies. Some records point to the knowledge of diamond dust, the hardest natural substance on Earth. If such a precious abrasive was mounted onto a cutting disc or the end of a drill bit, perhaps set into a soft metal like bronze, it could account for the smoothest finishes and most precise undercuts. This would represent not a secret tool, but a secret ingredient, a sophisticated application of material science that has simply faded from the historical record. The evidence for it is not in a preserved toolkit, but in the flawless results themselves and in the logical path a master craftsperson would take. They would seek the most effective material for the task. The disappearance of this knowledge is perhaps the greatest testament to its value. In a world where trade routes shifted and empires fell, the specific recipe for the perfect slurry or the source of a rare abrasive could become a guarded secret and then a forgotten one. The stones, however, remember, their mirrored surfaces and sharp geometry stand as permanent proof that their makers understood something we are still piecing together, that true mastery lies not in the force you apply, but in the cleverness of the medium you choose to apply it through. But what if the secret ingredient was not a powder, but a pitch? This brings us to one of the most intriguing and controversial ideas in the search for lost techniques, the sonic or vibrational theory. It suggests that the ancients may have used sound itself as a tool. Across the world, from the Andes to the deserts of Egypt, there are legends that speak of stones becoming weightless, or moving to the rhythm of a chant, or softening under the influence of a specific sacred frequency. These stories, long dismissed as myth, are now being examined through the lens of modern physics. Every solid object, from a wine glass to a block of granite, has a natural resonant frequency. It is the specific pitch at which the object naturally vibrates. You have likely seen this principle demonstrated with a singer shattering a crystal glass by hitting and sustaining its exact resonant note. The sound waves transfer energy into the glass, amplifying its microscopic vibrations until the material cannot hold itself together and it fractures. Proponents of the sonic theory ask a profound question: what if this principle could be controlled not to destroy but to shape? Could a culture have learned to find the resonant frequency of a specific type of stone and then, using chanting, drums, or even specialized instruments, amplify that frequency with enough precision and power to temporarily alter the stone's state? The idea is that at the right frequency, the molecular bonds within the rock might loosen, reducing friction and making the stone momentarily more malleable, almost like a thick fluid. This could explain some of the most baffling observations. It might account for the seamless, flowing joints at Saxehuaman that look as if the stones were pressed together while soft. It could offer a reason for certain stone surfaces in ancient quarries that appear strangely smooth or slumped, as if the rock had once been in a plastic state. From a purely speculative standpoint, it even provides a narrative for how massive blocks could be transported with less effort if their effective weight was somehow reduced through vibrational levitation. However, this is where the theory meets the hard wall of mainstream skepticism. The energy required to achieve such an effect on a multi-ton block of granite with the technology assumed to be available is, by our current understanding, astronomically high. The control would need to be perfect, a single, pure frequency sustained across a vast area, something incredibly difficult even with our modern amplifiers and speakers. There is also no direct archaeological evidence, no ancient tuning fork or sonic device that has been recovered. Yet, the theory persists because it represents something vital about this entire mystery. It is the point where ancient anecdote and cutting-edge curiosity meet. It forces us to consider knowledge not as a list of tools, but as an understanding of the hidden forces within nature itself. Whether it was ever practically achieved is hotly debated, but the mere existence of the idea reminds us that our ancestors saw the world as an interconnected system of energy and matter. Their legends may not be literal instructions, but they could be metaphorical echoes of a profound truth, that the world is not always as solid as it seems, and that true mastery might lie in learning to listen to the hidden song within the stone. The marks left behind tell their own silent story. When you examine the tool marks on these ancient objects under magnification, a pattern emerges that feels unsettlingly familiar. The argument for advanced machinery is built not on speculation, but on the physical fingerprints of the tools themselves. On a saw cut through granite, you might find long, perfectly parallel striations, lines running straight and true from one end of the cut to the other. This is a signature of a saw blade moving with a fixed, consistent motion, not the wavering, back and forth arc of a handheld tool. Inside the cylindrical drill holes of Egyptian artifacts, you can sometimes see a faint, spiraling groove, but more telling are the tiny, concentric rings that run around the interior wall. These rings indicate a consistent feed rate, the steady, even pressure of a drill bit being pushed into the stone as it spins, a hallmark of a mounted, mechanically powered drill. Then there is the symmetry. The hard stone vases we discussed earlier exhibit a balance so perfect that their center of gravity is exactly aligned with their geometric center. This level of precision is the domain of the lathe, a machine that spins a workpiece against a fixed cutting tool. The idea is not that the ancients had gleaming factories, but that they may have mastered the fundamental principles of rotational mechanics. Think of a simple potter's wheel, but imagine one scaled up and powered not by a foot, but by a flowing river channeled through a water wheel, or even by a complex system of weighted gears. This would provide the smooth, uninterrupted rotary force needed for such flawless work. The theory, championed by researchers like engineer Christopher Dunn, forces a radical and uncomfortable question. Could a sophisticated technical knowledge have risen to a peak, only to be completely lost in a subsequent dark age? Our traditional view of history is a linear upward climb from simple to complex. This evidence suggests something different, a cycle of profound innovation and catastrophic forgetting. The concept is both frightening and exhilarating. It frightens because it implies that our own technological civilization is not a guaranteed pinnacle, but merely one point in a long, cyclical rhythm. It exhilarates because it opens the door to a far more mysterious and capable ancient world, one where human ingenuity may have reached heights we are only now beginning to recognize again. The stone itself becomes a kind of fossil, not of a biological creature, but of a thought process, a mechanical logic etched in granite for us to decode millennia later. The true secret might not have been a single tool, but an entire language of craftsmanship, spoken fluently from master to apprentice. This brings us to the most fragile element of the mystery, the transmission of knowledge itself. How do you teach a person to feel the moment a granite block is perfectly flat, or to mix a grinding slurry to the exact consistency that will cut cleanly without wasting the precious abrasive? The astonishing consistency we see from one pyramid casing stone to the next, or across the hundreds of identical components at Puma Punku, is the strongest evidence of all. It points to a system, a formalized and rigorous education that turned intuitive skill into a repeatable science. This was not a collection of individual geniuses working in isolation. It was a living tradition, likely maintained by a closed guild or a revered school of master artisans. Their knowledge was their power, their sacred trust, and they guarded it with immense care. Think of it not as a textbook, but as a symphony of practiced movements, a deep understanding of materials that was learned by doing, by watching, and by feeling the feedback from the stone itself. An apprentice would spend years, perhaps decades, learning the foundational skills before being entrusted with the secret recipes, the precise angles, the rhythmic techniques that separated adequate work from the impossible perfection we marvel at today. This knowledge was entirely practical, a living library stored in muscle memory and keen observation, passed from one generation to the next through silent demonstration and careful correction. This is why its disappearance is both so profound and so understandable. Such a tradition is breathtakingly vulnerable. It requires stability, continuity, and a society that values and supports its master crafters over centuries. A single period of great hardship, a war that disrupts the lineage, a famine that scatters the population, or a cultural shift that devalues the old ways, and the chain is broken. The exact pressure of a hand, the specific chant that may have set a resonant frequency, the precise mineral mix for the perfect polishing slurry, all of it evaporates in a generation. What remains are the stunning artifacts, silent and perfect, while the living wisdom that created them fades into silence. The techniques become unexplainable not because they were magical, but because the human thread that carried them was severed. We are left with the magnificent fossil, but the species that created it is extinct. This perspective shifts the mystery from a search for objects to a meditation on the fragility of human knowledge. It asks us to consider what profound understandings we ourselves hold today that are not written down, but live only in the hands and minds of a few, and how easily that light could be lost to the shadows of time. The granite floor of an Egyptian quarry holds a ghost, a monument that never was. The unfinished obelisk of Aswan is a colossal failure, a 1,000-ton giant that cracked and was abandoned where it lay. Yet this silent, broken project is perhaps our single greatest window into the ancient stoneworker's world. It is an open-air textbook, its lessons carved not in hieroglyphs, but in the very scars of its creation. All around the obelisk's outline, you can see the deep, narrow trenches workers painstakingly hammered out of the living bedrock. They did this not with metal, but with other stones, using balls of dolerite, a rock harder than granite, to pound away grain by grain. The method is visible, logical, and brutally slow. We can understand this phase. It is a testament to immense human labor and perseverance, a story of force and time. But this understanding creates a new and deeper puzzle. The obelisk represents the raw beginning, the brute force extraction. When we compare this rough, split stone still clinging to the earth to the finished, mirror-polished perfection of a royal sarcophagus or a temple column, the gap feels unbridgeable. How do you get from here to there? The unfinished obelisk shows us the rough draft, but the editing process, the transformative steps that turned a quarried block into a precision object, remains almost entirely missing from the archaeological record. The trenches prove how they got the stone out of the ground. They do not explain how they made its surface flat enough to see your reflection, or how they carved intricate symbols into that unforgiving surface with such crisp clarity. This stark disparity highlights a potential truth we often overlook. The quarrying phase and the finishing phase may have been two entirely different worlds of technology. The pounding with dolerite balls was the work of many, a coordinated effort of mass labor. But the final shaping, the polishing, the perfect inscription, that may have been the guarded domain of a master class, using techniques and tools far more refined than stone hammers. The obelisk's failure, therefore, freezes a moment in time. It lets us see the starting line with absolute clarity, which only makes the finish line seem more distant and miraculous. It forces a humbling question. If the initial, brutish step is this difficult, what unimaginable skill must have been required for the final touch? The secret does not lie in how they separated stone from earth, but in how they then convinced that stone to obey their will, to become smooth, precise, and sacred. That transition is the true black box of ancient craftsmanship, and the cracked giant in Aswan is the key that makes us realize just how much we have yet to find inside. The quarry floor in Aswan shows us the starting point, but the journey from raw stone to polished perfection remains hidden. Perhaps the greatest clue to that hidden journey comes not from a pharaoh's tomb, but from a quiet field in 20th century Florida. Here, the ancient mystery finds a modern echo in the story of one determined man and his impossible castle. Edward Leedskalnin was a slight, 5-foot-tall Latvian immigrant who arrived in America with little more than a profound sense of purpose. Over the course of nearly 3 decades, working almost entirely alone and under the cover of night, he single-handedly created one of the most baffling attractions in the modern world, the Coral Castle. From the local bedrock, he quarried, carved, and precisely positioned over 1,000 tons of oolite limestone, a dense coral rock. He fashioned a massive 9-ton gate that rotated with the push of a single finger. He built towering obelisks, intricate furniture, and a functioning sundial accurate to within 2 minutes, all cut and fitted with astonishing precision. When asked how he managed such feats, Leedskalnin would only offer a cryptic smile and say he had rediscovered the secret of the pyramids. He claimed to understand the laws of weight and leverage that the ancient builders had used. His methods were a closely guarded secret. He worked behind a high wall of coral blocks, often at night, and would stop his labor if anyone came too close. This deliberate shroud of mystery has, of course, fueled endless speculation about anti-gravity devices or forgotten energies. Yet the most plausible explanations are elegantly simple, rooted in the very principles he hinted at. Investigators and engineers who have studied the site believe Leedskalnin likely mastered and profound, intuitive understanding of leverage, fulcrums, and counterweights. He may have used simple tripods, chains, and handcrafted winches to move massive blocks by shifting their center of gravity incrementally, turning an impossible weight into a manageable series of tiny, controlled movements. He probably employed homemade tools and relentless patience, understanding the material's properties intimately. The true power of the Coral Castle story is not in proving ancient techniques, but in serving as a powerful metaphor for the larger mystery. Here was one man with no formal engineering education, using basic principles to accomplish what onlookers deemed magical. His story demonstrates that a deep, almost instinctual grasp of physics and material science can yield results that appear supernatural to those who do not possess the knowledge. It reminds us that the gap between impossible and possible is often just a matter of understanding. If a lone individual in the modern era could create such a monument and guard its secrets so completely, it becomes far easier to imagine how an entire guild of ancient masters, working within a protected tradition, could achieve wonders that leave us speechless millennia later. Leedskalnin's castle stands as a modern monument to a timeless truth that profound knowledge once held closely can vanish as completely as a whisper in the wind, leaving behind only the physical proof that it once existed. The silent language of numbers is carved into every perfect seam. To truly grasp the stoneworking mystery, we must move our focus from the hand to the mind, from the tool's edge to the architect's plan. This impossible precision was not achieved through blind effort or accidental genius. It was the direct result of a profound and sophisticated intellectual framework, a deep mastery of geometry and mathematics that guided every strike and every measurement. Think of a modern skyscraper. Before a single steel beam is lifted, teams of engineers have spent thousands of hours on blueprints, calculating load, stress, and alignment down to the millimeter. The ancient master builders operated on the same principle, just with a different set of tools and a different notation for their calculations. Their blueprints were not on parchment, but in their understanding of universal principles. The evidence is everywhere you look. The perfect right angles inside the Serapeum boxes are not a happy accident. They are a geometric statement, achievable only with a method for establishing a true 90-degree corner and the ability to check it repeatedly. The flowing, interlocking curves at Saxehuaman are not random organic shapes. They are deliberate, complex curves that had to be planned and replicated across dozens of irregular blocks so they would fit together in 3 dimensions. This demands more than a good eye, it requires a system. Cultures like the Egyptians encoded advanced mathematical concepts into their very culture. We know they had a practical understanding of pi, the ratio of a circle's circumference to its diameter, which appears in the proportions of the Great Pyramid. They understood the golden ratio, a proportion found throughout nature that the human eye perceives as inherently balanced and beautiful. This was not abstract classroom theory, this was applied science. This knowledge was the invisible scaffold upon which the physical stone was hung. Before any block was quarried, the master planners would have used this geometry to create full-scale templates, perhaps out of wood or stone, that defined the exact shape of each component. They would set out building lines on the ground using stretched cords, employing the ancient equivalent of a surveyor's string line. They would use simple but brilliant tools like sighting rods and water levels, which use the immutable property of water to find a perfectly horizontal plane, to ensure that foundations were flat and courses of stone were level across vast distances. The stone itself was then shaped to conform to this geometric ideal. A builder might use a set square, a simple tool forming a right angle to check the corner of a block. They might use a curved template to guide the cutting of an arch or a niche. The process transformed raw, chaotic rock into a precise component of a larger, mathematically harmonious whole. This reveals the deeper layer of the mystery. The unexplained technique is not just about what tool cut the stone, but about the intellectual system that told the craftsman exactly where to cut and to what tolerance. It was a silent language of numbers, angles, and proportions, passed down through generations and made manifest in rock. The true secret may have been this shared mental architecture, a unified way of seeing and shaping the world that allowed thousands of workers across centuries to contribute to a single, coherent vision of perfection. The stones are not just heavy, they are eloquent. They speak in the quiet, certain voice of mathematics, a language we are still learning to hear. The smooth, polished surfaces of the ancient world present a direct challenge to modern understanding, a challenge that has not gone unanswered. In workshops and quarries around the globe, a new breed of researcher has taken up the task, not with books and theories, but with sweat and stone. This is the field of experimental archaeology, where the only way to test an idea is to try to build it yourself. Teams of dedicated individuals have spent years attempting to recreate the ancient feats, using only the tools and materials we believe were available. They have tried to carve granite vases using copper-tipped drills and simple abrasives like sand. They have attempted to shape blocks of andesite, the same dense volcanic rock found at Puma Punku, using nothing but stone hammers. They have organized groups of volunteers to move multi-ton megaliths using wooden sledges, rollers, and miles of heavy rope. The results of these painstaking experiments are always informative, but they are also consistently humbling. They prove one thing with absolute certainty, that certain tasks are technically possible with a near infinite investment of time and sheer human effort. A team can, over many months, eventually produce a rough approximation of a stone vase. They can, with enough people pulling, inch a massive block across the ground. What these experiments almost never achieve, however, is the breathtaking finesse of the originals. The experimental vase will have walls of uneven thickness, its interior curve will be clumsy, and its surface will be rough and pitted from the grinding process. The moved block will be scarred and cracked from the journey. The ancient artifacts, by contrast, speak of a process that was not just about raw possibility, but about mastered efficiency and flawless quality control. This gap is where the real mystery deepens. The experiments highlight the staggering investment of time the ancients were clearly willing to make, a testament to their cultural dedication. But they also underscore a glaring missing factor, a kind of lost leverage. They force us to ask a critical question. Did the ancient masters possess a simple, clever trick that we have yet to rediscover? Was it a specific, superior abrasive mix, perhaps using crushed emery instead of common sand? Was it a perfectly designed wooden jig or frame that held a drilling tool perfectly steady, transforming erratic effort into smooth, consistent rotation? Could it have been an ingenious water lubrication system that kept a cutting slurry cool and flowing, preventing the abrasive from clogging and dramatically speeding up the work? One modern researcher, using a copper saw with a slurry of quartz sand, found it took over 12 hours of continuous back and forth motion to cut just 1 inch into a granite block. Now multiply that by the thousands of cuts in a single temple. The math becomes a monument to exhaustion. But what if their secret ingredient made that same cut take only 1 hour? That is not a trivial difference. It is the difference between a project lasting a single lifetime and one requiring 50 generations. The search for that lost efficiency, for the elegant shortcut hidden within the apparent grind, is the quiet, ongoing heart of experimental archaeology. Every failed attempt, every rough replica that falls short of ancient perfection is not a defeat. It is a clue narrowing down the infinite possibilities, teaching us not just how it might have been done, but more importantly, how it almost certainly was not. The surface of the stone holds a story written in scratches too fine for the naked eye to see. To read this hidden text, science turns from the chisel to the microscope, entering a realm where every tiny groove becomes a line of evidence. This is the world of petrographic analysis, a forensic investigation of stone itself. By slicing incredibly thin sections of an artifact and examining them under polarized light, or by studying surface marks with high-powered digital microscopes, researchers can uncover a detailed biography of how that stone was shaped. They are not just looking at scratches, they are reading a narrative of force, motion, and material. The direction of microscopic striations tells them if a tool moved back and forth in a sawing motion or in a continuous circular path. The depth and shape of these grooves can hint at the hardness and size of the abrasive particles used. Even the sequence of operations becomes clear. You can see where a rough grinding pass was followed by a finer one, and then finally by a meticulous polishing stage. This is hard, empirical data, a direct conversation with the craftsmanship of the past. On some Egyptian granite artifacts, this microscopic scrutiny has revealed long, perfectly parallel striations. These are not the wavering marks of a handheld saw pulled by muscle alone. They are the signature of a blade moving with fixed, mechanical consistency, the kind produced by a circular saw mounted in a stable frame. On other objects, the story is one of refinement. The surface shows layers of treatment, beginning with coarse gouges that were systematically ground away by progressively finer powders, culminating in that legendary mirror finish. This evidence points to a deliberate, multi-stage finishing process as sophisticated as any modern metal or woodworking technique. Yet, for every question this forensic approach answers, it seems to unveil two more. The ultimate goal would be to find and identify the exact abrasive mineral clinging within those microscopic grooves. Discovering particles of corundum or another ultra-hard mineral would be a revelation, confirming the lost slurry hypothesis with concrete proof. But such a definitive fingerprint has remained elusive. The stones have been cleaned by time, or perhaps the ancient polishing was so thorough it left no residue behind. So we are left with a powerful contradiction. The microscope shows us the clear, logical steps of an advanced process, but it withholds the final, crucial ingredient. The recipe for that perfect polish, the exact mix of grit and liquid, remains encoded within the stone's own crystalline memory, a secret it has kept for thousands of years, revealing its methods but guarding its materials. A polished granite sarcophagus was never just a container. It was a philosophical argument carved in mineral, a declaration meant to outlast the sun itself. To understand the relentless pursuit of perfection in ancient stonework, we must look past the how and ask the deeper question, why? Why choose the most difficult material imaginable? The answer lies in the profound symbolism stone held across these disparate cultures. It was the physical embodiment of permanence, a bridge between the fleeting human world and the timeless realm of the gods and ancestors. Granite does not erode like sandstone. Basalt does not crumble like clay. By shaping these eternal materials, the builders were making a statement that was intended to be literally unbreakable. In Egypt, a king's body resting within a 70-ton granite box was a guarantee of his eternal reign, his legacy secured in a substance as enduring as the cosmos. The technical impossibility was the entire point. It was proof of a divine mandate, a power that could command the very bones of the earth. The flawless work was not for human admiration, but for cosmic validation. This shifts our perspective dramatically. The seamless, interlocking walls of an Inca fortress were not merely a clever defense. They represented the unbreakable unity of the empire itself, Tawantinsuyu, the land of the four quarters. Each stone, uniquely shaped yet perfectly bonded to its neighbors, mirrored the ideal of a society where every individual and province locked together into an indestructible whole. The wall's fusion with the living bedrock beneath it symbolized a sacred harmony with Pachamama, Mother Earth. The structure wasn't built upon the land, it was woven into it, a testament to an ideology of connection and stability. This reveals a transformative idea that the technical mastery we find so baffling was never an end in itself. It was in service of a spiritual or ideological goal. The perfect joint, the mirror polish, the impossible precision, these were not feats of engineering alone. They were acts of devotion, physical prayers offered in stone. This understanding opens a door to a possibility modern material science often overlooks. The unexplained technique might be deeply intertwined with ritual practice. What if the process of carving was as sacred as the finished product? Chronicles from the Spanish conquest mention that Inca stoneworkers sometimes employed songs and rhythmic chanting while they fit massive blocks together. We might dismiss this as folklore, but consider it through the lens of intention. Could these practices have been methods of achieving unparalleled group focus and synchronization, turning a team of laborers into a single, coordinated organism? The act of shaping the eternal stone may have been surrounded by ceremony, purification, and states of concentrated intention that we simply do not factor into our equations of man-hours and tool hardness. The modern mind separates the spiritual from the technical, but for these cultures, that line may never have existed. The flawless cut was a spiritual achievement, the polished surface a reflection of inner purity. When we look at these monuments and see only a puzzle of physics, we might be missing half the picture. The true secret ingredient in the ancient workshop may not have been a hidden tool or a lost alloy, but a state of mind, a collective purpose so powerful it allowed human hands to perform what we can only describe as miracles. The stone was not just being shaped, it was being consecrated. This pattern of impossible precision is not confined to the deserts of Egypt or the mountains of Peru. If we widen our gaze across the globe, the same enigmatic signature appears again and again, etched into different landscapes by cultures that should have had no contact with one another. Take the subterranean world of Malta. Beneath the island's quiet surface lies the hypogeum of Saflieni, a vast, multi-level temple complex carved entirely from the living Globigerina limestone. Its walls are smooth and flowing, with rounded chambers and arched ceilings that feel organic, almost sculpted by water rather than tools. But the true wonder is not just in the carving, it is in the sound. Certain rooms within the hypogeum are engineered with astonishing acoustic properties. A voice spoken in one chamber can resonate throughout the entire underground structure, creating an otherworldly echo that seems to amplify the human spirit. This was not an accident of excavation. The smooth, curved surfaces were deliberately shaped to manipulate sound, suggesting the builders possessed a sophisticated understanding of resonance and vibration as part of their sacred architecture. How did they achieve such smooth, controlled curves in solid rock and to such a precise acoustic effect? Then, journey to the jungles of Costa Rica, where we find objects that defy simple categorization. Scattered across the landscape are hundreds of stone spheres, some as small as a basketball, others towering over 2 meters in height and weighing many tons. They are carved from granodiorite, a hard, igneous rock. Their most baffling feature is their near-perfect sphericity. Many are so precisely round that modern measurements reveal only the tiniest of deviations. The process of creating a perfect sphere from such hard stone is a monumental challenge of geometry and consistency. You cannot achieve this with random hammering. It requires a method for constantly checking the curvature from every angle, a systematic process of pecking and grinding away stone evenly from all sides until the ideal form emerges. Were they symbolic representations of celestial bodies or markers of some forgotten cosmic alignment? Their purpose is debated, but their craftsmanship speaks a universal language of precision. Perhaps the most staggering example of ambition, however, is found in India. At the Ellora Caves, the Kailasa temple stands not as a constructed building, but as a sculpture of unimaginable scale. Around the 8th century, workers began not at the ground, but at the top of a towering basaltic cliff. They then carved downward, chiseling away an estimated 200,000 tons of solid rock in a subtractive process that lasted generations. What they left behind is not a built structure, but a monolithic temple complex complete with intricate pillars, detailed sculptures of deities and elephants, and multi-storied galleries, all excavated from a single piece of stone. The scale of planning is mind-bending. One mistake in the initial phases, one misjudgment in the depth of a cut, and the entire project could have been ruined. This was architecture in reverse, an act of revelation rather than construction, uncovering a sacred space that was believed to exist within the mountain itself. When we place these sites side by side, the smooth acoustic chambers of Malta, the perfect spheres of Costa Rica, and the cliff-revealed temple of India, a powerful pattern comes into focus. These are not isolated curiosities. They are individual expressions of a recurring phenomenon where ancient cultures, separated by vast oceans and millennia, repeatedly pushed their stoneworking capabilities to a threshold that strains our standard historical models. Each culture used the materials at hand, each worked within its own spiritual and artistic tradition, yet all arrived at a similar pinnacle of technical mastery. This pattern forces a profound question upon us. Did these civilizations, in complete isolation, independently stumble upon remarkably advanced methods for shaping stone? Or does this recurring theme of impossible craftsmanship hint at a deeper, older root of knowledge, a shared wellspring of geometric and technical understanding that has since been lost to the great expanse of prehistory. The stones in their global chorus suggest our past may be far more interconnected and far more ingenious than any single history book has yet dared to claim. Time itself has become a silent collaborator in this ancient mystery. The very forces that were meant to erode these monuments have, in many cases, added a final, enigmatic layer to their appearance. The glassy sheen on a granite block, the impossibly smooth curve of a limestone wall, these are not always the direct signature of a master's tool. They can be the patient artwork of climate, a natural finishing process spanning thousands of years. Wind carrying fine grains of sand acts like a planetary sandblaster, slowly scouring and polishing exposed surfaces. Rain, subtly acidic from atmospheric gases, chemically weathers the stone, dissolving minute particles and leaving behind a smoothed patina. This process can soften or even erase the microscopic tool marks that researchers desperately seek, blurring the crucial line between human artistry and geological accident. In some extraordinary instances, the effects of nature provoke even more dramatic theories. At sites like Baalbek in Lebanon, observers have noted that the surfaces of some megalithic stones appear almost vitrified, as if they were subjected to intense, focused heat that partially melted the rock surface. While mainstream geology often attributes such appearances to natural crystalline structures or chemical leaching, the visual effect is startling and fuels ongoing debate about whether some form of applied, high-temperature technology could have been used, either to shape the stone or to seal it. More commonly, however, the challenge is subtler. A patina, that thin, often darkened film that forms on stone over centuries, can act like a natural filler. It settles into the finest scratches and grooves left by ancient tools, effectively smoothing out the microscopic landscape. A surface that might have had a slight texture when first carved can, after millennia, appear as smooth as poured glass. This presents a profound dilemma for accurate analysis. Is the flawless finish we admire today the intended masterpiece of the builder, or is it the graceful veil of time? Disentangling these effects requires forensic science. Researchers use advanced imaging to look beneath the patina, searching for the original texture. They compare sheltered surfaces protected from the elements with those exposed to the full force of the environment. This painstaking work reminds us that the objects we study are not frozen in the moment of their creation. They are dynamic, having conversed with wind, water, and chemistry for ages. To find the true hand of the artisan, we must first learn to listen to the long, slow story told by the stone itself. The stones are silent, but the society that moved them must have roared with coordinated effort. Behind every perfectly fitted block lies a hidden world of logistics, a social machine of breathtaking complexity. The true wonder may not be the individual chisel mark, but the master schedule that directed thousands of hands over countless seasons. Think of the modern construction of a skyscraper, a ballet of cranes, crews, and precisely timed deliveries. Now remove the cranes, the trucks, the power tools, and the digital blueprints. What remains is the pure human architecture of will. To quarry a 200-ton obelisk, transport it across miles of desert, and then raise it vertically required more than strong backs. It demanded a society organized with military precision. There had to be managers who could plan the project years in advance, engineers who understood leverage and hydraulics to move the impossible weight, and master craftsmen who could execute the final, flawless cuts. Most fundamentally, it required a vast labor force freed from the daily struggle to find food. This is the crucial, often overlooked foundation, a robust agricultural surplus. Farmers had to produce enough grain not only for their own families, but to feed armies of stoneworkers, draft animals, and the administrators overseeing it all. This surplus allowed for specialization, the birth of the full-time artisan whose entire life was dedicated to learning the language of stone. The projects we marvel at were not the work of a single brilliant king or a lone genius sculptor. They were the legacy of generations, a sacred baton passed from father to son, from master to apprentice, across a span of time longer than most modern nations have existed. This social dimension is, in itself, a core part of the technical explanation. The technique was not just a tool, it was a tradition sustained by a stable, hierarchical, and profoundly dedicated culture. Their ability to coordinate such sustained, complex effort over decades is a monument to human cooperation, rivaling the physical structures they created. Yet this very insight deepens the central mystery in a haunting way. If a temple took 150 years to complete, how was the original vision preserved? How did the fifth generation of workers know the exact angle intended by the first generation's architects? How were quality standards enforced over a century, ensuring that the final capstone matched the precision of the foundation laid lifetimes earlier? This suggests a social machinery of knowledge transmission, just as sophisticated as the stoneworking itself. There must have been a rigid, revered system of templates, oral teachings, and ritualized practices that embedded the geometric ideals into the culture itself. The master builder was not just a foreman, he was a keeper of sacred standards. This intricate social organism, however, was as vulnerable as it was powerful. It depended on continuity, on peace, on a steady flow of resources, and on an unbroken chain of mentorship. A single prolonged drought, a devastating conflict, or a shift in royal patronage could shatter that chain. The knowledge, so carefully guarded and so dependent on lived experience, could evaporate within a few neglected generations. The physical stones would remain, eternal and perfect, while the living, breathing society that knew their secrets turned to dust. The greatest loss, then, may not have been a secret chemical or a magical tool. It may have been the collapse of the intricate, fragile school that taught humanity how to speak to the mountain. The ancient mason's workshop may have been a laboratory of a deeper philosophy. To understand the stone, we must sometimes look beyond the physical tools and into the realm of ideas that shaped the craftsman's mind. This brings us to a fascinating and often misunderstood tradition, the legacy of alchemy and Hermetic knowledge. In popular culture, alchemy is remembered as a misguided search to transform lead into gold. But at its heart, it was a profound philosophical system concerned with the purification and perfection of all matter, including the human spirit. The famous Hermetic principle, as above, so below, suggests a mirroring between the macrocosm of the universe and the microcosm of the earthly realm. For a master stoneworker, this was not an abstract theory. It was a practical guide. The dense, chaotic rock from the quarry represented the base, unrefined state of matter. The act of cutting, grinding, and polishing that stone into a flawless geometric form was an act of alchemy in itself, a process of bringing a lower material into a higher state of order to reflect the perfection believed to exist in the celestial spheres above. This worldview transforms our image of the ancient artisan. They were not merely skilled laborers following a set of instructions. Within this interpretive lens, they were philosopher-scientists operating within a holistic framework where practical skill and spiritual understanding were inseparable. The craft was a sacred act, the knowledge required to soften a stone's resolve or to mix the perfect abrasive slurry would have been guarded not just as a trade secret, but as sacred wisdom. This idea finds echoes in later traditions. Secret societies like the Freemasons, whose very name and symbolic tools, the square, the compass, the plumb line, are drawn directly from the stonemason's trade, preserved this link between moral geometry and material craft. Their rituals speak of building not just temples of stone, but temples of the self. This raises a compelling possibility. Could the unexplained technique we have been searching for be part of a lost body of operative knowledge? a unified discipline that blended practical chemistry with a deep, intuitive philosophy of materials. Perhaps the search for a plant-based compound to soften granite was not just a quest for a better tool, but an alchemical experiment. Perhaps the precise, rhythmic chanting reported during some building processes was a method of aligning the worker's intention with the hidden vibrational nature of the stone itself, a practical application of as above, so below. In this view, the flawless finish is not just a technical achievement, but a signature of a completed spiritual process. The stone has been transformed, and in doing so, it has transformed the space around it into something sacred. This perspective does not provide a manual for how to cut granite. Instead, it offers a reason why the standard explanations feel insufficient. We are trying to analyze a sacred science with the tools of secular engineering. We are looking for a chemical formula when the recipe might have included elements of ritual, intention, and a worldview that saw the universe as a living, resonant whole. The true secret may have died not with the loss of a tool, but with the fading of an entire way of seeing the world, a way in which the hand, the mind, and the spirit worked in concert to converse with the very substance of the earth. Our own 21st century tools, for all their power, cannot travel back in time. This is the ultimate limitation in our search for answers. We can create breathtakingly detailed three-dimensional scans of an ancient artifact, mapping every microscopic groove. We can run complex computer simulations to model the stress on a stone block, yet these are all models, reflections of a reality we can no longer touch. The scientific method, the bedrock of our modern understanding, demands reproducible evidence. We need to be able to run the experiment again and again, controlling the variables. But how do you reproduce a singular historical event, a cultural moment that unfolded over generations and then vanished? The workshop is closed, the masters are gone, and the living tradition is silent. We are left with the difficult art of reverse engineering, trying to deduce a process from its finished product alone. It is like finding a perfectly baked, intricate cake and trying to guess not only the recipe but the exact oven and the baker's state of mind, with only the final crumbs as clues. The challenge is made even more profound by the very efficiency of our own technology. Modern diamond-tipped saws and laser cutters work with such speed and power that they obliterate the stone in a clean, violent instant. They do not leave behind the same kind of subtle, telltale marks that a slower, more laborious ancient process would have created. Using our advanced tools to replicate ancient work is often like using a chainsaw to recreate the delicate marks of a handsaw. The method itself destroys the evidence we are trying to understand. This places us in a humbling paradox. We possess more raw technological power than any ancient civilization, yet that very power may blind us to simpler, more elegant solutions. Our paradigm values speed, efficiency, and scalability. We solve problems by applying more energy, more computing power, more force. But what if the ancient paradigm valued something entirely different? What if the primary goals were spiritual integrity, perfect harmony with natural law, and the creation of an object that was not just built but consecrated? In that framework, time was not a limiting factor to be minimized, but a sacred resource to be invested. The journey of shaping the stone was as important as the destination. This fundamental difference in worldview may be the greatest barrier to our comprehension. Their techniques might not be merely unexplained, but in some ways fundamentally unexplainable within our current framework of thought. We are trying to decode a language of craftsmanship where the vocabulary includes states of focused intention and cultural meaning that our instruments simply cannot measure. The true secret may be that we are not just missing a tool, we are missing the lens through which they viewed the very act of creation. A flawless granite surface is more than a technical marvel, it is a question mark etched directly onto our timeline. This niche mystery of stone carving matters precisely because it refuses to stay in its niche. it spills over, challenging the very framework through which we view human history. For generations, we have embraced a linear, progressive model, a comforting narrative that charts a steady climb from simple stone tools to complex silicon chips. We imagine history as an upward slope, where each generation stands on the shoulders of the last, accumulating knowledge in a neat, unbroken chain. But these impossible stone artifacts are stubborn data points that do not fit that smooth curve. They are outliers of such magnitude that they force us to redraw the graph entirely. If we genuinely accept that the methods for creating these objects are lost, not merely obscure, but completely absent from our understanding, then we must confront a radical idea. Human knowledge is not always cumulative. It can be cyclical. It can be gained, concentrated into a golden age of specialized mastery, and then scattered to the winds by time, conflict, or simple forgetting. This introduces the profound possibility of peaks and troughs in technological capability, where a society reaches a zenith of skill in a specific domain, only for that pinnacle to later vanish from collective memory. This isn't about resorting to tales of lost continents or extraterrestrial intervention. It is a far more grounded, and in some ways more haunting, realization about the nature of civilization itself. It asks us to acknowledge the sheer fragility of complex practical knowledge. Consider a master craftsperson's wisdom, a deep, tactile understanding of materials, angles, and forces that lives in the hands and the eyes, passed down through demonstration, not textbooks. That knowledge is a living flame. It requires a stable society to feed it, a continuous line of dedicated apprentices to carry it, and a cultural purpose to sustain its relevance. Sever that chain of transmission and the flame gutters out. The principles behind the perfect polish or the seamless joint become not secrets but empty spaces. The society that follows might be advanced in other ways, with new arts and new technologies, yet completely incapable of replicating the stonework of its own ancestors. This reshapes our view of cultural resilience and innovation. A civilization is not a monolithic block of progress, but a tapestry where brilliant threads can be pulled loose and lost, even as the overall pattern continues to evolve. What does this mean for us today, in our age of digital archives and global networks? It is a humbling lesson in epistemic humility. We tend to assume that our current understanding represents a permanent plateau, that once a discovery is made, it becomes a permanent part of the human toolkit. The stones whisper a cautionary tale. They remind us that our own vast edifice of knowledge, for all its digital fortifications, is still vulnerable. It depends on stable systems, on continuous energy, on social coherence. The true impact of this mystery, then, is not just a revised chapter in archaeology textbooks. It is a philosophical shift. It invites us to see history not as a straight line we are drawing, but as a spiral where deep truths can be discovered, forgotten, and perhaps one day discovered again in a different form. The legacy of these ancient masons is not merely their monuments, but the silent, enduring question they pose to our modern certainty. How much of what we know could slip through our fingers, and what masteries might we have already let go? The quest for a single, magical secret is a compelling story, but it likely misses the true picture. The solution to this ancient riddle probably wasn't one grand invention, but a masterful synthesis of many known elements, combined and optimized to a degree we have yet to fully replicate. Imagine a recipe where every ingredient is crucial, but the exact proportions and the order of mixing are what create culinary magic. The ancient mastery of stone may have worked in a similar way. They had access to superior abrasives like crushed emery or corundum, which are significantly harder than common sand. They likely developed specialized, mechanically clever tools, not futuristic machines, but ingeniously designed bow-driven lathes, tube drills mounted in stable frames, and saws that could hold a cutting slurry effectively. Beyond the tools, they possessed a profound, hands-on understanding of the stone itself, an intuitive grasp of fracture mechanics learned through generations of direct experience. They knew which grain to follow, where to apply pressure, and how to listen to the material's feedback. This technical prowess was then multiplied by a social engine of immense power, a culturally unified society with a sacred motivation, capable of organizing thousands of workers and sustaining a project across multiple lifetimes with unwavering quality control. The true unexplained element, then, might not be a missing component but the lost art of perfect combination. It was the optimized system, the standard operating procedure refined over centuries, that turned difficult tasks into routine achievements. The loss of that integrated system, the breaking of the chain that passed down the precise recipe, is what created the chasm in our understanding. What was once a well-understood craft became, to later eyes, an inexplicable marvel. This perspective is both humbling and illuminating. It suggests the ancients were not in possession of secrets beyond our physics, but were supreme optimizers within the laws of nature. They took the principles of leverage, abrasion, and geometry and pushed them to an absolute limit, driven by a purpose that made the investment of time and effort not just acceptable but sacred. Their legacy is a testament to what human culture can achieve when knowledge, skill, and collective will are aligned toward a singular, enduring vision. The stones stand not as proof of a lost super technology, but as monuments to a lost peak of human ingenuity, a peak built not on one secret, but on the symphony of many. That final, perfect seam is a testament to what we can still learn. Our journey through these silent workshops of the past reveals something profound, not just about the stones, but about us. We have stood before the seamless walls of Saxehuaman, felt the impossible geometry of the Serapeum boxes, and traced the machined edges of Puma Punku. We have listened to the theories, from lost abrasives to forgotten sciences, and weighed the evidence left in every microscopic groove. While a single, definitive answer may remain carved just beyond our reach, the pursuit itself transforms our view of history. These monuments are far more than ancient puzzles or artifacts. They are enduring questions given solid form, challenging our assumptions at every turn. They ask us to remain humble in the face of our ancestors' achievements and endlessly curious about the depths of human capability. Perhaps the greatest lesson etched into all this granite is a simple, powerful truth. The people who came before us were not primitive precursors to our modern world. They were innovators, philosophers, and engineers of the highest order, capable of vision and execution that still leaves us in awe. Their legacy is a reminder that human ingenuity can reach staggering heights, and that those heights can, tragically, be lost to time. This mystery, therefore, is not a failure of our understanding, but an invitation. An invitation to keep looking at the ancient world with wondering eyes, to question the stories we have been told, and to appreciate the quiet genius locked in stone. If this exploration has sparked your own curiosity, the conversation is just beginning. We would love to hear your thoughts and theories in the comments below. For more journeys into history's deepest enigmas, be sure to subscribe. And remember, the next time you see an ancient wall or a weathered statue, look a little closer. You might just be staring at a question that has waited for thousands of years to be asked.